Hi, hello, and welcome to Problem Solving and C Programming. In this session, we are going to see about C data types and sample programs. Myself, I am Dr. Uma, professor in the Department of Computer Science and Engineering from Hindustan College of Engineering and Technology, Coimbatore. Data types are an integral part of a programming language. In this session, we are going to discuss about the various data types that are available in C programming. A data type is nothing but a set of values and a set of operations that can be applied on those values. So the topics that are discussed in this session are void type of data, integral type of data, floating point types. Now let us have a look into this. This slide was earlier seen. So we are going to discuss about integral type of data and floating point type of data. To begin with that of the character type data, we can have two types of character definitions for C programming language. One is the normal character set that is used in other programming languages as well in order to represent ASCII character set, or it can be that of ISO 8859 character set, and the next one is that of the wide character set, which is used to hold 16 byte wide character that is represented as the Unicode UTF-16LE. Next is the type of integers that are available in C programming language: short int, integer, long int, long int. As the picture tells us, short int is of smallest size, then comes the size of integer, then comes the size of long int, then comes the size of long int. So they are in increasing order of size from short int to long int. So that is indicated in this particular slide. In this slide, we are having a mention of the type of the various type of integers, the byte size of each of these data types, the minimum value and the maximum value that can be held in a data variable which is defined to be of those that are defined over here on the left hand side. Next comes the floating point type of data. We can have three different variations of floating point types. They are float, double and long double. As mentioned in this picture, float is of the smallest size, then comes long double, then comes long double. Sorry, double and long double. Double and long double. The increasing order of size of these data types is mentioned in this slide. Here we are having a summary of the various different types of data that are used in C programming language. Void, it is of a single type of data. It means nothing. Integral, it can be of Boolean, character or integer. Floating point, it can be either real or imaginary or complex. So the various implementations of these floating point types mentioned as real or float, double and long double. Under imaginary, we have float imaginary, double imaginary, long double imaginary. For complex floating point type of data, we can have float complex, double complex, long double complex. Variables. Variables are named locations that have a type such as integer or character which is inherited from their type. The type determines the value that a variable may contain and the operations that may be used with its values. The topics of discussion in this session are variable declaration and variable initialization. Let us see how variables could be declared in a C program. This is a simple program statement segment that has a declaration of different types of variables used in a C program. Here we are having character type of variable, integer variable, long variable, floating point variable and double variable. Here we are having an extension of the same slide that is shown earlier. We are having different types of variables declared over here. In addition to having a single variable declared in a single program statement, it is possible to have several variables declared in a single program statement separated by comma. That is what is illustrated in this particular slide. An example for initialization of the variables as soon as they are declared is shown in this program segment. Here This code variable is declared as character type data, and the initialization value for this code is mentioned over here. Similarly, I, in addition to being declared as an integer type data, is also assigned with the value of 14 in this statement. Similarly, we have the other variables declared over here along with their initialization values that are mentioned on the right hand side of the equal to symbol of the variable names. It should be noted that when a variable is defined, it is not initialized. So it is required that we have to initialize any value if we need the prescribed data before the function starts. So this is a program example. In order to print the sum of three numbers, this program segment begins with the comment statement indicating what this program is meant for, or what the problem is this program is going to solve. Followed by this, we have a preprocessor directive hash include stdio.h, which directs the compiler to include the header file stdio.h. Followed by this, we have the main function definition, starting with the open curly brace. Then we have local declarations. Three variables a, b, and c are defined as integer. We are having a variable sum that is also declared as integer type data in order to hold the output. The program statements are given over here. Welcome. This program adds three numbers, enter three numbers in the form n, 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 n. Okay, so then followed by this, we are having a scanf statement. The scanf is a input statement which is used to get values for the variables that are declared after the double quote and a comma, and the names of the variables into which these values are to be stored are given on the right hand side of this comma. So %d refers to this integer specifier. It is used for getting an integer input, and this ampersand a refers to the variable name where this particular value will get stored into. This ampersand refers to the memory. So here this scanf statement takes or reads three different integer inputs and stores the values in the variables a, b, and c respectively. After getting the values, we are summing up these three values with the plus operator. The plus operator is meant to perform the summation, that is integer summation, because we are using integer variables as a part of the computation statement. After computation, this value will get stored into the variable name that is listed on the left hand side of the equal to symbol. So in this case, it will get stored into the name sum. After this, we are using a printf statement in order to print the output. The total is %d. This refers to the integer specifier, and two null line characters are given as input to the printf statement in order to provide an aesthetical output. Then we have thank you, have a good day. Then we are having return 0 in order to satisfy the return type of the main function. Close curly brace in order to end the main function definition. Now let us see how the output will look like. Welcome. This program adds three numbers, enter three numbers in the form triple n, triple n, triple n. So the input given by us is 11, 22, and 33. It displays the output as the total is 66. Thank you. Have a good day. So this is what is the output generated. Now let us have a look into constants. Constants are data whose value will not get changed at the time of execution of the program. So let us see how a constant could be represented and how we can make use of the constants within the coding as well. A character constant is enclosed in single quote. Examples of several ASCII characters and the symbolic notation of each of these ASCII characters are given in the left hand side and right hand side respectively. The mostly used ASCII characters are null character, alert symbol, backspace, horizontal tab, new line tab, vertical tab, form feed, carriage return, single quote, double quote and backslash. And the symbolic names for each of these are listed on the right hand side against each of these ASCII characters that you can verify. Null character is represented by \0 enclosed in single quote. These are the symbolic names for control characters which will have a variation in the output on introducing these within the output functions. Examples of some integer constants are given over here. These values refer to integer type of data, integer type, long int, unsigned long int, long int. Examples of real constants are given over here. The type of the data that refers to this value are given here: double, double float and long double. So this is how we have to represent strings. A string has to be enclosed in double quotes because this is enclosed in double quote. This is a string. If it is enclosed in single quote, it is a single character. \0 refers to a null character, and double quotes without any characters inserted refers to an empty string. It should be noted that single quotes are used for representing character constants and double quotes are used for representing string constants. So this is an example for memory constant definitions. This program demonstrates 3 different ways how the constants could be used within a program. This is a preprocessor directive #include stdio.h. This is already seen. #define, this is under preprocessor directive, which represents that this is the value for the constant pi. Whenever we are defining any constant under the #define statement, we represent them in all caps. So this is the main function definition. Return type is integer and we are not passing any values as input for the main function. Here we have local declarations. Under the local declaration, we are defining constant pi. So we are giving a different type of variable name here. Here you could see that it is in all caps. Here we are having a variation of this. Constant pi is made equivalent to pi. So this will assign the value 3.1415926.536 to CPI. Then we are having a printf statements in order to print the values of this pi as well as this CPI. Then we are having the value itself given as input in this printf statement, and it is made to get displayed onto the screen using the floating point specifier %f. Followed by that we have the return statement, return 0, then close curly brace in order to mark the end of the main function definition. So on execution of the above program, we get the output as is mentioned over there. Okay, so we could see that there is no difference between the 3 different ways of mentioning the constant. With that, we conclude the introduction for the C programming language. Thank you.